Well, the first lesson in chapter 2 just deals a little bit more with solving equations. And guess what? There's no exponents in this lesson, so we can be excited. The first little clue that we're going to give you is that sometimes it helps to clear an equation. Good grief, I said equation. Did you hear that? Hope you thought that was funny. Let's try that again. Sometimes it helps to clear the equation of fractions or decimals, because sometimes that makes them look like too complicated. So we can use the multiplication property to eliminate them. So I have written an equation right here that has fractions. 3/4 x plus a half equals 3/2. So the way we clear this of the fraction is I'm going to find the least common denominator that these two have, which would be 4. 2 and 4, the least common denominator is 4. I want to multiply both sides by 4 to get rid of this fraction. So I group them together to help you see this. I'm going to multiply this side by 4 and the other side by 4. I've got to do the same to both sides to make it fair and equal and everybody get along. So when I do that, I'm just rewriting it right here just to show you what I'm doing. The 4 is going to be distributed across 4 times 3/4 x and 4 times a half equals, and we have to multiply 4 by 3/2 over here. When I do that, here my 4's cancel out. I get rid of my fraction. They become 1. 4 over 4 is 1. So I have 3x plus 2 will go into 4 2 times. So now I'm left with 2 because there is just a 1 up here in this numerator. Equals 2 goes into 4 2 times, and 2 times 3 is 6. So now I have this nice and neat little equation here that I can simply solve by putting my variables on one side and my constants on the other. So I took away a 2 over here, took away a 2 over here. Now I have 3x equals 4. Divide both sides by 3 to get my variable by itself. And I solved it for x equals 4/3. If you want to test that out and make sure you got it right, you can plug 4/3 back in to your original equation for x and see if you get 3/2. It's a good way to check it. I did another one like this in blue beside it, except this time I used decimals. 12.4 take away 3.64x equals 1.48. Well, if you don't want to deal with all those decimals, just get rid of them. Multiply both sides by, I picked 100 because of this right here. This decimal went to the hundredths place, so that would help me get rid of that decimal completely. So I showed you right here how I grouped them. I'm going to multiply this entire side by 100 and multiply my answer by 100 to keep everything all fair and equal. Everybody's going to get along. When I do that, I got 1240 take away 364x equals 148. When you put your variable on one side and your constants on the other, I'm going to take away 1240 from this side. Same over here. I'm left with negative 364x equals negative 1092. And when you divide both sides by negative 364, you get 3. Now, yes, Mrs. Starr, if you just work it out on your calculator with your decimals, aren't you going to get the same thing? Yes, you are. But I'm just showing you an easier way to do it in case you're not allowed to use a calculator. Ha ha ha. We'll have to see if Mrs. Starr lets you or not. Now, sometimes we have equations with parentheses, and we've seen a lot of those, I know, in Chapter 1. So this actually doesn't look quite as scary as the ones in Chapter 1 that we dealt with. We know if we have an equation like this, we can use the distributive property to get rid of our parentheses. We want to get rid of those. So I just distributed 3 across the 7 and the negative 2, and I got 21, negative 6x. And on this side, didn't have to do anything to the 14. I distributed my negative 8 across the x and the negative 1. So I got negative 8x plus 8. Then we know we want to get our constants on one side, our variables on the other side, all our like terms together. And that's what I did. And I know that you know how to do this. And after I did that, I got all the way down to 2x equals 1. So I had to divide x equals 1/2. So the little clues down here are guidelines for solving equations. Yes, I want you to write these down. First, distribute across to help you move those parentheses. You can't do anything inside the parentheses. You need to go ahead and distribute. Clear your equations of any fractions or decimals if you have to. Collect your like terms on both sides of the equation, and then use your addition and multiplication properties to get that variable all by itself. All by myself, I wanna be all by myself. I don't know if y'all know that song. Just thought I'd share that. So, here's another one with some parentheses. And I'm going to distribute my 3 across the y and negative 1. So I have 3y, take away 3. This 1, nothing can be done with it, so there it is. Equals 2. And now I'm going to distribute my negative 5 across the y and the 5. Negative 5y minus 25. So I kind of shortened this a little. I had a negative 3 and a negative 1, so it became negative 4. Over here I had, oh, I'm so sorry. I started right on there and didn't mean to. Oh, sorry about that. Over here I have a 2 and a negative 25, so that's negative 23. Then I'm going to move all my y's on the left, all my constants on the right. I added a 5, so I added a 5 over here, 8y. Should have said I added a 5y. Over here, I added a 4 to get rid of that. Added a 4 over on this side, got negative 19, divided by 8 now. So y equals negative 19/8. Here we might have something a tad bit new. It's called the principle of zero products. And we know that anytime we have numbers, if a times b equals 0, one of these can equal 0, and it's going to make the whole thing equal 0. Well, look, if we have an equation set up like this, x plus 4, and all of that is times x minus 2, and the whole thing equals 0, I know that if this equals 0, x minus 2, well, the whole thing is going to equal 0. If this equals 0, x plus 4, then the whole thing is going to equal 0. I could figure out what would make that 0, and it would be a solution for this problem. So I set x plus 4 equal to 0, and I got x equals negative 4. So if I put negative 4 in there, that's going to be 0, and so the whole thing's going to be 0. I could have another solution too. What if this was 0? So I set x minus 2 equal to 0, worked it out, and figured out, well, if x is 2, that's going to be 0, and the whole thing's going to be 0. So I have two solutions to this problem. I could have negative 4, or I could have 2. I'm going to show you one example, and then we'll do some more tomorrow. And I chose this one because it comes out a freaky fraction. Oh, I like that term, freaky fraction. Anyway, notice I have negative 2 plus 5 in parentheses, and I'm multiplying it by 5x plus 1. and the whole thing equals 0. So just like above, if this part equals 0, the whole thing equals 0. And if this part equals 0, the whole thing's going to equal 0. So if I just take it apart and play with negative 2x plus 5 and figure out what would make it 0, and when I work all that out, it becomes 5 halves. If I put 5 halves in here, it turns this whole section into 0. And then when 0 is multiplied by anything else, we get 0. So one of my solutions is 5 halves. Well, I could do the same thing with the other side. What would make 5x plus 1 equal to 0? Well, I set it equal to 0, and I solve for x, and I figure out that, hey, negative 1/5 would make it equal to 0. If you don't trust me, put it in there and see. And so I have two solutions to this problem, 5 halves and negative 1/5. So we'll be working on problems like this tomorrow in class. I hope you enjoyed that lesson and my lovely song edition. Thank you very much.